Here in example 2, we've got a cylindrical can which is made to hold 1 liter of oil. Find the dimensions that will minimize the cost of the metal to manufacture this can. So we've got two things. We've got how much it holds, so the volume of the can, and then they want us to minimize the cost of the metal. So the metal would be the outsides of the can or the surface area. The surface area of the can is what we are minimizing. So we're going to make an equation for the volume. We're going to make an equation for the surface area, and then we're going to find the derivative of the surface area since that is what we're trying to minimize. So that's our plan. Let's get started. So you've got this can of oil, and they say that it holds 1 liter, which is approximately 1,000 cubic centimeters. And then we know the volume of a cylinder would be the area of the base times the height. So the area of the base, if we're talking about a circle, is pi r squared, and then times the height. So that's the volume, and we've got 1,000. And so if I divide by, well, let's just leave it there. So this is what we know about the volume. Now let's talk about the surface area. Well, surface area, we got to think about what is the can made out of. The can is made out of a top, a bottom, and a rectangle. The top and the bottom, we've got two circles. So we've got 2 pi r squareds, two circles. Plus, we've got the rectangle. Now, if the rectangle is wrapped around the circle, so the length of the rectangle is the circumference, and the height of the rectangle is the height of the can. So the area of the rectangle is going to be 2 pi r h. Now there's too many variables here to find the derivative. So what we're going to do is get rid of h using the h that I know over here. So I'm going to solve for h, divide by pi r squared. And that's what I'm going to fill in for h over here before I find my derivative. And we want to simplify this as much as we can before we start doing the derivative, because the derivative can be complicated. So we want to make it as uncomplicated as possible. My pi's cancel. I'm going to get 2,000. And then the r's reduce, and r reduces. And so I have an r on the bottom, which I'm going to write as r to the negative first. Now I'm going to find my derivative. So I'm going to get 4 pi r, and the negative comes in front. I'm going to get negative 2,000 r to the negative second. And I want to set this equal to 0 because I'm trying to find the minimum surface area so that I can minimize my cost. I'm going to write this as a fraction so that I can solve this easier. And I'm going to get a common denominator down here. So that's going to be cubed now on top. And then I'm going to just set the top equal to 0 because if I multiply that r squared to the other side, it'll just go away. So if I set the top equal to 0, I'm going to find my radius for the minimum. So let's set the top. Add 2,000 to the other side. Divide by 4, you get 500. Divide by the pi, and you get 500 over pi. And then take the cubed root to get r by itself. So this r is going to minimize my surface area. If I plug that in and find the minimum height, so let's go to where we solved for height. So, because they asked for the dimensions of the can. So here's the radius, that would give me the minimum surface area. And then if I plug that in, I can find my height, that would be minimum surface area. So without a calculator, we're gonna just leave this crazy looking thing alone. That would be my minimum height. And if you want to check to make sure that it's a minimum, here I made a table just to check my values. I just went up to 1,000 just because it told me a volume of 1,000, but you can go up to infinity if you want, even though it won't go up to infinity. I started at 0 because we're not going to go below 0 area. And if we know that this thing is approximately 5, because I typed it into a calculator, if you test something small into your derivative, you get a negative. If you test something big in your derivative, you get a positive. So it did decrease and then increase, which tells me that it was a minimum for that R.